Before we continue our discussion on functions, I want to introduce you to some notation we'll be using in this section called interval notation. Interval notation is a really convenient way to write inequalities, and I have a list of 4 inequalities here. Let's start by looking at x greater than or equal to 2. If I were to graph this inequality on the number line, it would look something like this. X greater than or equal to 2 means all values that are larger or to the right of 2, and then I put a closed circle at 2, indicating that that's also part of my solution. In interval notation, I would write this as bracket 2, comma, infinity, parentheses. Basically, in interval notation, we list the endpoints of the interval. So I would say that the shaded region starts at 2 and ends at, well, it never ends, so we'll say it ends at infinity. We always put parentheses at infinities, and we use the square bracket when we want to actually include that number. The 2 is included in my answer. Whereas x less than 9 indicates all numbers smaller than 9 to the left of 9, but now I put an open circle at 9 because 9 is actually not part of that interval. In interval notation, I would write this as negative infinity to 9, using parentheses with both. Again, we always list the endpoints of the interval, always going from left to right. Put parentheses with your infinities. And this time I did a parenthesis with the 9 to indicate that 9 is actually not included in that interval. This 3-part inequality, negative 3 less than x less than or equal to 4, basically means our x's are anything between negative 3 and 4. Notice I did an open circle at negative 3 and a closed circle at 4, because the 4 is included, but the negative 3 is not actually part of the interval. In interval notation, I would write this as negative 3 to 4, with the parenthesis with the negative 3, the bracket with the 4. Again, the bracket means there's a closed circle, we're including that number. The parenthesis means there's an open circle, we're not including the number. Finally, x less than negative 1, or x is bigger than positive 3, refers to the ends of the number lines. The x's could be smaller or to the left of negative 1, or they could be bigger or to the right of positive 3. Because I can tell that I'm talking about 2 separate intervals, 2 separate shaded in regions on the number line, I have to write this as 2 separate intervals with my interval notation. The left side would be everything from negative infinity to negative 1. The right side is everything from 3 to infinity. Now I stuck a U between my intervals. This is standard notation. The U actually stands for union, or you can think of it as meaning the word or. In this course, it's not important to remember what that means, but just know that we're going to put U's between our intervals to connect them. Okay, back to our discussion of functions. I'm going to give you 2 vocabulary words today, domain and range. Domain refers to the set of inputs of a function, the x's that go into that function, and the range is the set of outputs, or the y values, that you get from that function. So let's start by finding domain and range if we're given a graph. Again, domain refers to all of the x's that the graph exists for. And so in this first image, it looks like the graph starts with an x value of negative 3 and stops with an x value of 6. I write my answer in interval notation. The domain is everything from negative 3 to 6. I did the square brackets because we've got closed circles, we're including the endpoints. Now the range is all of the y values that the function exists for. And so reading this graph from the bottom to the top, it looks like the smallest y value is negative 7, and the largest is positive 2. In interval notation, that's everything from negative 7 to 2, again with those brackets because of the closed circles. In my second example, domain again is the x's, so I'm reading the graph from left to right. And because I have arrows on both ends, that means that the graph is actually continuing forever to the left and forever to the right. So my domain is actually all real numbers, or in interval notation, I can write that as negative infinity to positive infinity. The range is the y values. I read this graph from the bottom to the top. The smallest y value I see is negative 3. And this graph goes up forever, so the range is negative 3 to infinity. Let's do one more graph. Domain is the x's. I read the graph from left to right. The graph starts with an x value of negative 3, stops with an x value of negative 3. The range is the y values. This graph has y values that range from negative 8 to positive 8. Now, how do we find domain if we don't have a graph, if we just have an equation? I've got two rules listed on the screen for you. The first one is if you have a rational function, which is basically an algebraic fraction, the rule is we're not allowed to divide by 0. The denominator can't equal 0. Division by 0 is undefined. If you have a radical function, something with a square root, the rule is we can't take the square root of a negative number, so we take the thing inside the square root, set it bigger than or equal to 0. These are really the only two restrictions we're going to have in this class. So I'm going to add a third case. Basically, everything else we see in this class is going to have a domain that is all real numbers. So let's do some examples. Part A, f of x equals x squared plus 1. I do not see a fraction. I do not see a square root. So this is case 3. There's no fraction, there's no square root. So my domain has to be all real numbers. Basically, that's what that's telling me is I can plug any number I want into this function, and I'll never get an undefined or an error. We can also think about this problem visually. Because we have a quadratic function, the graph would have to be a parabola. It would have arrows on both sides. So go to the left forever, go to the right forever. Domain is all real numbers. Examples B, C, and D are all rational functions. They're all fractions. And so I'm going to approach these problems the exact same way. The rule for a fraction is the denominator can't equal 0. So in part B, that means x cannot equal 0. On the number line, we're talking about every single point except for the 0. The domain is everything I have shaded in on that number line. I can write that in interval notation as everything from negative infinity to 0, so that's everything smaller than 0, and everything from 0 to infinity, everything bigger than 0. Notice removing that 0 cuts the number line into two pieces. That's why I have to write two intervals for my domain. Part C is also a rational function. So we do the exact same thing. We look at the denominator. That cannot equal 0. If I subtract 4 from both sides, I get x cannot equal negative 4. So on the number line, we're talking about every single point except for negative 4. So we write that as two intervals, everything from negative infinity to negative 4, and everything from negative 4 to infinity. Notice I have parentheses at the negative 4. That's important because negative 4 is not in the domain. Now you don't have to draw a number line every single time you do one of these. I'm drawing the number lines right now just so you have a picture in your head and so you can see where that interval notation comes from. But the answer is actually the interval notation part. That's what you're going to enter in for your homework. And so there's no need to draw the number line if you can kind of figure that out in your head. Okay, one more fraction. We're going to do the same thing. Denominator can't equal 0. This time I have a quadratic equation though, and so I'm going to have to solve this by factoring. Product of 8, sum of negative 6, that would be negative 4 and negative 2. So that means x cannot equal 4 and x cannot equal 2. Those are two numbers that would give me zeros in the denominator. Removing two numbers from the number line divides that into actually three intervals, and so our domain is everything smaller than 2, everything between 2 and 4, and everything larger than 4. That's all numbers except for 2, except for 4. Again, notice I used the parentheses in the interval notation. That's really important. That's because we're saying that the 2 and the 4 are actually not part of that domain. So now let's do some examples of radical functions, functions with square roots. The rule for square roots is that the thing inside the square root cannot be negative. And so if we look at example E, square root of x, that tells me that the x has to be bigger than or equal to 0. So the domain would be everything from 0 to infinity. This time I put the square bracket on because I want to include the 0. The 0 is actually okay. It's part of my domain. I'm going to do the same thing for examples f and g. They are square root functions, so it's the same rule. I take the thing inside the square root, set it bigger than or equal to 0. To solve, I add 2, and that gives me x is bigger than or equal to 2. In interval notation, that's everything from 2 to infinity. Same idea for the last one. The thing inside the radical has to be bigger than or equal to 0. To solve, I would subtract the 5 from both sides. And then we have to divide both sides by negative 2. However, anytime you divide an inequality by a negative number, you always have to flip the direction of the inequality. So that actually gives me x less than or equal to 5 halves. And if x is less than a number, we're now talking about the left side of the number line. And so in interval notation, that would be everything from negative infinity to 5 halves. Now there's many of other types of functions that you might see, but keep in mind that all of the other functions that we deal with, whether they're absolute value or polynomials, they have domains that are all real numbers. The only time we have restrictions is if we have fractions or square roots. Hope this helps with this section, and let me know if you have any questions.